Hi everyone, welcome back to the final part of the PSLV rocket mesh with GridPro. In today's video, we will explore the process of creating the blocking for the booster within the existing topology. We will then proceed to generate the final mesh and demonstrate how to mirror it to transform it into a complete PSLV launch vehicle grid. Before starting to modify the topology, set the work plane on YZ plane and reduce its size. Take a section for ease of viewing the surfaces. Corner group 1 has the middle sheet group from which we will remove some corners to carve a topology for the booster. Notice that the booster base is slightly rounded. Keep the corner group 1 as a reference and select the highlighted corners in another two empty corner groups. We will remove these step by step. Using edge length tool to move a sheet little outside of the nozzle. Now, use the remove tool to remove the corners grouped in C2. This created a space to accommodate the booster forebody. Move the corners around the nozzle to somewhat away. And add the insert as shown to adjust the nozzle. Hold A key and click on the highlighted edge to take the perpendicular sheet. Repeat the same process. Now remove the corners grouped in C3. Select the booster forebody, that is surface with ID 45, and assign the corners around the booster to it using generic tool under the assignment panel. This helps in grouping the blocks for reference. We have all the blocks around the booster added in group C1. Correct the assignments for all the surfaces of the booster. Align the corners assigned to the nozzle surface and move it closer. Wrap the blocks assigned to the surface with ID 45 by 0.1%. Notice the O-type topology around the forebody which is ending at the nozzle surface. Subsequently for the nozzle surface by same percentage. Select the surfaces which needs to be assigned to the guiding surfaces and also align it once it is assigned. Move the faces assigned to the guiding surfaces little outside on the convex side of it. We need to move only the corners that are assigned to the guiding surface, excluding all the corners that are assigned to the nozzle. This is not a very necessary step, but it helps in for better conversions. Notice the O-type topology now created for the nozzle surface as well. Now, select the blocks assigned to the guiding surface and do an internal wrap with insert. This created a one-to-one connected blocks from the guiding surface. Save the topology. Checking the validity shows that the topology is valid and we are good to go for our initial grid. Run the G-grid for dump frequency of 500 with half density. Take a slice to view the grid for the booster as shown. Looking at this grid, we see that there is a need to balance the density to avoid the bad quality at the booster rear end curvature. The grid around the nozzle and forebody looks to be fine. We will now balance the density at the rear end and around the booster. Run the grid with half density again. Notice the improvement in the grid. The quality of cells is increased and the cells are not skewed now. Now restart the grid with default density and run it for 500 sweeps. This is the final grid that is generated with more refined and better quality cells around the full PSLV model. We can transform and rotate this grid by angle of 72 degrees to view the full rocket body grid. Thank you for watching. If you like this video, leave us a like and subscribe to the channel for new videos. If you have any questions or any comments, feel free to leave it below. If you want us to post tutorials on any specific geometries, you could write to us on support@gridpro.com. Follow us on our social media pages. Links are posted in the description.